All right, let's talk about taking back control. For the last couple of years, it's felt like all the most powerful AI lived way up in the cloud, behind corporate APIs. But that game is changing fast. We're going to explore how you can run some incredibly powerful AI models right on your own computer, and more importantly, why you'd even want to. Let's get right into it.
I mean, if you've used any of the big AI tools out there, this probably sounds familiar, right? You're paying those monthly fees, you're getting constantly reminded that your data is being hoovered up for training, and sometimes the model just flat out refuses to do what you ask because of some corporate content policy. It really feels like you're just borrowing someone else's tool and you have to play by their rules.
And this quote, it just nails what we're talking about today. What if, instead of just renting access to AI, you could actually own it? I mean, really think about that. No data harvesting, no corporate guardrails telling you what you can and can't do, and absolutely no monthly bills. That's the huge promise of running language models locally, on your own hardware.
So here's how we're going to break it all down. First up, we'll get into that whole renting versus owning idea. Then we'll put local and cloud AI head-to-head in a showdown. After that, we're diving deep into the VRAM bottleneck. Seriously, it's the most important piece of hardware you need to understand. Then we'll build a fun tier list for different AI tasks, and we'll wrap it all up with a smart hybrid strategy that gives you the best of both worlds.
So how in the world did we even get here? For the longest time, AI basically meant these enormous server farm-sized models that no normal person could ever run. But, there's been this quiet revolution happening in the background, and it's all thanks to the rise of a whole new class of model that's made powerful, personal AI a real thing.
And they're called small language models, or SLMs. But hey, don't let that name fool you. These things are mighty. Thanks to way better training data and much smarter designs, these compact models are now strong enough for a ton of the tasks we used to need those giant cloud models for. Their killer feature isn't just their size, it's that they're accessible. You can run them. This table really lays out the trade-offs, doesn't it? As you can see, the big LLMs, the giants from Google, OpenAI, Anthropic, they're still the undisputed kings of super complex, high-level reasoning. But just look at that SLM column. They win on hardware, cost, and speed. They run on the gear you probably already have. The only cost is electricity, and the speed is just incredible because there's no network lag. This is opening up a whole new universe of real-time, private AI stuff.
Okay, so this brings us to the main event, local versus the cloud. And the key thing to get here is that it's not about which one is better in some absolute sense. It's all about which one is better for you and what you need to do, because they offer totally different things when it comes to control, cost, and what they can actually do.
This slide really gets to the heart of it. Cloud models are aligned. That's a fancy way of saying they operate under corporate rules. Now that's great for enterprise safety, but it can feel pretty restrictive. Local models, on the other hand, can be completely uncensored. They follow your instructions, period. Your data stays on your machine. You have total control right down to the model's core programming. This makes them absolutely perfect for creative work, private research, really any task where you need to be the one in charge.
Okay, so let's say you're sold on this whole local AI thing, but what do you actually need to run it? Well, this brings us to probably the most crucial technical idea we'll talk about today, the VRAM bottleneck. And it all comes down to your graphics card.
VRAM, that's video RAM. It's the super fast memory that lives right on your GPU. And here's the thing you have to remember. When you're running language models, the speed of your memory is way more important than the raw number crunching power of your chip. Memory bandwidth, not flops, is the real bottleneck.
I love this analogy. Think of it like this. Your VRAM is your workbench. It's not huge, but every single tool you need is right there, within arm's reach. It's lightning fast to grab whatever you need. Now, your regular system RAM, that's like a giant warehouse. Sure, it can store way more stuff, but every time you need a tool, you have to stop what you're doing, walk all the way over there, and get it. That trip is what absolutely kills your speed.
And this isn't just some abstract idea. Look at this real-world data from a regular 8GB graphics card. When the entire model fits on the workbench, our VRAM, it's pumping out text at 55 tokens per second. That's like reading speed fast, it feels great, but the second the model gets too big and has to spill into the warehouse, our system RAM, the speed just collapses. With a heavy spill, it drops to less than 2 tokens per second. That is unusably slow. Keeping the entire model on your GPU is absolutely not negotiable if you want a good experience.
So why does the speed fall off a cliff like that? This number is why.
Your GPU's VRAM is almost 10 times faster than your system RAM. The moment your super fast GPU has to stop and wait for data to be fetched from that slow warehouse, your entire operation just grinds to a halt. The GPU is just sitting there, twiddling its thumbs, waiting. That is the bottleneck in action.
Okay, now that we get the hardware, let's get strategic, right? You wouldn't use a sledgehammer to hang a tiny picture frame. The exact same logic applies to AI. The really smart way to do things is something called Inference Arbitrage, which is a fancy term for just using the cheapest, fastest model that can actually get the job done. So let's build ourselves a tier list.
We're going to start at the very top, S tier. These are the tasks where local models aren't just some cheap knockoff. They are often flat out the better choice because they win on the things that matter most for these jobs: speed, privacy, and your control.
Just look at these use cases. For code autocomplete, you need responses in milliseconds. A local model is just faster, no contest. For creating images, local models let you completely sidestep those annoying content filters and train your own custom styles. And for transcribing your meetings, you get near instant and, more importantly, completely private speech to text. These are massive, massive wins for local AI.
But of course, we gotta be real about the limitations. So let's talk about the C tier. These are the really complex, reasoning-heavy tasks where the pure scale and super advanced architecture of those frontier cloud models still give them a pretty big lead.
Things like agentic coding, where an AI has to plan and actually make edits across a whole bunch of files, or trying to debug a really gnarly software bug. That stuff requires a level of reasoning that the smaller, local models just haven't quite reached yet. Same for really long back-and-forth conversations with a voice assistant. For these super high-end tasks, you're still going to want to reach for a top-tier cloud model.
And all of this brings us to the final and honestly the most practical part of this whole thing, because you don't have to pick just one side. The truly smart workflow is a hybrid one, an approach that uses the unique strengths of both local and cloud models together.
This table shows you exactly how it works. You basically create a routing system. Simple, private stuff, like generating boilerplate code. That goes to your free local model. For bigger jobs, you just escalate up the API tiers, only paying for the brain power you actually need, when you need it. This means you could handle the vast majority of your day-to-day work for free, and only pull out your wallet for that tiny fraction of tasks that truly needs a frontier-level genius.
Now, you might be sitting there thinking, this sounds really complicated to set up. But the tools have gotten so good, it's wild. You can be up and running with your very first local model in, and I'm not kidding, less than 2 minutes.
By far, the easiest way to jump in is with a tool called Llama. It's just a single download. Once you've got it installed, you just pop open your terminal and type Llama run and then the name of the model you want. In this case, Qwen 3.5, that champion for 8 gig cards we saw earlier. That's literally it. You are now chatting with a powerful AI that is running 100% on your own machine.
So, let's recap the big takeaways here. First, the main idea. Own your intelligence. Don't just rent it from someone else. Second, VRAM is king. For that snappy speed, the model has to fit entirely on your graphics card. Third, use a smart hybrid strategy. Route the easy stuff locally and save the cloud APIs for the real heavy lifting. And finally, maybe the most important takeaway of all, you can start doing this today. The tools are ready for you right now.
We are really moving from an era where AI was this big, centralized thing to one where it's a personal tool, something that's tailored to you, controlled by you, and running on your own hardware. The possibilities are just starting to open up. So the real question is, what are you going to build with it?